11.1 and 11.2 are about arc length and sector area. We're dealing with circles here. So our essential question, I have two of them for you. How can you find the length of a circular arc? And the other essential question is how can you find the area of a sector? And before we get started, we should review a couple things about circles. So first of all, the first question I've posed to you is how many degrees are in a circle? So hopefully you know this, but if you don't, I gave you a picture here. And if you think about yourself maybe being at this point right here, and maybe you think about like this is like your x-axis and this is your y-axis, or basically a horizontal axis and a vertical axis. And you start here, and you go up to the vertical axis. Well, you've got 90 degrees, right? And you do that again, you've gone 180 degrees. You do that again, you've gone 270 degrees, and you get back to where you started. That's 360 degrees. Think about twirling, right? Maybe a ballerina, right? You do a 360, or a skateboarder, you do a 360. I'll also maybe use my compass to show you this. So if I put my compass point in the center, and I basically rotate all the way around the circle, having the pencil here go all the way around the circle, then inside here what I've done is I've gone around 360 degrees. All right, so how many degrees are there in a circle? There are 360 degrees in a circle. That's really important, and if you don't know that, you need to write that down. You need to remember that. My other question I have for you is what is the central angle of a circle? Okay, so I'm going to go over a couple pieces of vocabulary here. First of all, the central angle, we'll highlight that with a different highlighting color. Okay, a central angle is basically an angle whose vertex is at the center of the circle and whose sides are the radii that intersect the circle. Okay, so let's write that down. Central angle is an angle whose vertex is at the center of the circle and whose sides are radii. How about intersecting the circle? So our central angle here is basically the angle AOB. So it's this angle right here, right? That's going to be our central angle. So in our example here, angle AOB is our central angle. Or you can call it angle BOA. So I'll go ahead and I'll highlight that. Now in addition to that, I'd like to talk about what an arc is. So this portion of the exterior of the circle that's being intercepted by these two radii that create the central angle, we call that an arc. So let's see, I'm going to use green for this. So this portion right here is what we'll call an arc, or a circular arc, and I'll highlight that in green. Okay, so it's the portion of the circle, the exterior of the circle, that is being intercepted by the central angle or by the sides of the central angle. All right, I have a couple things for us to think about. So if you're given a central angle, if a given central angle in a circle is 90 degrees, what percent of the circle does that central angle represent? So for example, if I did the central angle that used these two radii right here, right, that would be a 90-degree central angle. Well, what percent of this circle does 90 degrees represent? Well, how many of these are there? Well, I've got this one, not 90 degrees, but I've also got this one, right, from 90 to 180, there's another 90 degrees. From 180 to 270, there's another 90 degrees. And from 270 to 360, there's another 90 degrees. So I truly have 4 of those, right? Okay, so we can say, we can do this a couple ways. You can do it visually and say to yourself, yep, that's a quarter. Or you can take the number of degrees that you have. So anytime it asks, what percent of the circle do you have? The way that you find the percent of the circle every single time is you take that central angle and you divide it by the total amount of degrees in the circle, right? So total, that's how you find the percent of anything, right? You take the part that you want over all of it. Well, in this case, if I have 90-degree central angle, okay, so I've got 90 degrees over 360 degrees. Well, like we said, that was 1/4, right? And 1/4 is the same as 25%. So you can do it visually. It's important to get used to seeing that the percent of the circle, though, is the central angle over the total degrees. And if we're talking about a circle, that's going to be 360 degrees every single time. Every single time. The central angle is going to change. All right, number 2. If an arc measures 60 degrees, what percent of the distance around the circle does that arc represent? Okay. So an arc measure, the degrees here, or this arc, is basically related to that central angle, right? If this central angle is taking up a quarter of the circle, like a 90-degree angle would be, so maybe I should be looking at this one here. Okay, if you look at this arc right here, that arc is taking up a quarter of the entire outside of the circle. So once again, you need to know that that's a quarter, or this central angle is a quarter of the circle. And then you can figure out the percent of the distance around, basically using this exact same type of formula, right? Okay, so if an arc measure is 60 degrees, what percent of the distance around the circle does that arc represent? Okay, so percent, again, of circle is always going to be that central angle, okay? And the arc measure, if the arc measures 60 degrees, that tells us that the central angle is going to also be 60 degrees, okay? So it's going to be central angle, which is the same as the arc measure. Oops, I didn't spell arc right. Over the total amount of degrees. And again, in a circle, that's going to be 360 degrees. Total degree symbol up there too. Okay, so for this one, the arc measure is 60 degrees this time, not 90 degrees. So we're going to do 60. What percent of the distance around the circle does that arc represent? Well, out of 360 is going to be 1/6. If you divide 1 by 6, you end up getting like 0.166666666. So I'm just going to approximate this to be about 16.7%. Let me circle these. So this would be my answer to number 1. This would be my answer to number 2. And we're using the exact same idea of just figuring out what percent of the circle are we dealing with. And to figure out what percent of the circle you're dealing with, you realize, okay, so how much of the central angle do I have, or what is the measure of my central angle, and put that over the total amount of degrees. Okay, once upon a time, you learned about circumference. Now, circumference is basically the distance around a circle. So it's like the perimeter of a circle. So this is distance around a circle. And there was a formula that you learned for circumference. You learned that circumference would be the same as 2 times pi times r. Well, 2 times r, right, if you double the radius, you get the diameter. So you could also look at it like this. Circumference equals pi times diameter. Those are exactly the same thing. So that's your formula for circumference. You're going to want to know that. It's basically the perimeter of a circle. I don't know why we call it circumference instead of just perimeter. But those are the exact, those mean the same thing because 2r is the same as diameter. 2 times radius is the same as diameter. Uh-oh, my highlighter went through. That's okay. All right, so we're going to find each indicated measure. So we're going to find the circumference of a circle with a radius of 11 inches. So circumference is equal to 2 pi r. Or circumference is equal to 2 times diameter. Oops, I did that wrong. Pi times diameter. I did it right on the other side, right? Let's make sure. Yeah, pi times diameter. Well, which one of these do I want to use? Well, the question is, what have I been given? So I've been given the fact that the radius is 11. So if I've been given the radius, then I know that r equals 11. So I might want to use this one. But if I do 2 times 11, I'll get the diameter. So that's 22. Either way, totally works. So the circumference here is 2 times pi times 11. So we're going to end up with, actually, I'll just equate it here. Let's do 22 pi. And this is the most exact answer. You can also put this into your calculator. So let me show you how to use your calculator with pi and get an exact answer. Because you're going to usually say, oh, pi is 3.14, but not necessarily. It's an irrational number, so it goes on and on and on forever. So I'm going to actually use my little pi button right here. So I just hit shift or second and pi. And then I can get an approximation, which is approximately, and I'll go 3 decimal places, 69.115. So either one of these, this is the exact answer. This is the approximate answer. Not sure which one your textbook will do. You should know how to do. Okay, so now we want to find the radius of a circle with a circumference of 4 millimeters. Oh, that reminds me, there's millimeters here, so there's inches here. So let's see, I found the circumference. The radius would have been in inches. This is just 2 pi times radius in inches. So my answer here should be in inches. So I'll put inches at the end. Again, it's perimeter, right? And if we think about going around a circle, like if let's say, for example, this was, I don't know, some kind of a horse pen or something, and I wanted to make it circular. Well, I'm going to think about putting fencing up, and it's going to be in linear feet, right? So it's a linear. I'm not looking for the area in between, so it's not square inches, it's linear. All right, so I've got 4 millimeters, and that's my circumference. So my circumference is 4 millimeters. I'll put millimeters. And I don't know what my radius is. That's the question. Okay, but I know that there's a relationship between the two, and it's circumference equals 2 pi r. I think I'll use that one instead of using the one with diameter, because this way I can actually find the radius directly. So I know that the circumference is 4. I'm going to put 2 pi r here, and now I'm going to solve for radius. Well, radius is being multiplied by 2 pi, so I'm going to divide both sides by 2 pi. So from there, the 2, see how the 2 and the pi, they're factors in the denominator? And then 4 also has a factor of 2. So I can reduce both of these or divide top and bottom by 2. So this will give me a 1 pi on the denominator. and in the numerator I'll have a 2. These completely reduce. Okay, so coming over here then, I have 2 divided by pi, and that's in millimeters, is going to equal my radius. And then if I wanted to get an approximation for that, okay, once again I go to my calculator, I do 2 divided by, and for me it's a shift and then this little pi. Don't use 3.14 because it's not exact. And I'll show you what I mean by that. So 0.637. So the radius here is about 0.637 millimeters. But I would also, this is a more exact answer, so this also works for me. Okay. Oops, dropping things. So now let's talk about arc length. So once again, if I were to draw a circle, and that circle has a central angle, so I have 2 radii of that circle intersecting at the center, then what's happening from point A to point B, I have this arc that maybe I want to measure. Or, so let's call this AB. I can actually do this a couple ways. So maybe I want the smaller length of the smaller arc, or maybe I want this larger length of this larger arc, right? So there's actually 2 arcs that are being formed. Well, again, let's just go from this, let's do the smaller one. From A to B, the length here is just going to be a fraction of the entire length around the entire circle. And we know that the length around the entire circle, we call that circumference. So really what we're doing is we're looking for a fraction or a percent of the circumference. So arc length is a percent of circumference. Oops, can't spell. Okay, so how do we find this? Okay, so let's actually get a calculation. Well, when we were trying to find the percent of a circle, we did the central angle over the total degrees. So we're going to find the percent of the circle, and then now that we're talking about arc length, we're going to take that percent of the circle and we're going to multiply it by the circumference, because it's a percent of the circumference. So the formula, and this is how I want you to be thinking about it, right? We want percent of the circle times circumference. Or in other words, we'll do the central angle we'll divide that by 360 degrees, and then we'll multiply that by the circumference, which is 2 pi r or pi d, depends on what you've been given. Okay, so let me highlight that because that's quite important. So arc length is always going to be the central angle over 360. That gives you the percent of the circle, and then you multiply it by the circumference. All right, we're going to find each indicated measure. So we want the arc length of arc. So this is how you actually write arc. It's just like a little arc over the 2 endpoints of that arc. So we are going from P to R, and we care about the arc between the 2. So I'm going to go ahead and highlight those. All right, well, the arc length of PR is basically going to be a percent of the circumference of the circle, right? So I need to know what percent the central angle is taking up, what portion, what fraction the central angle is taking. And I do that by putting that over 360. And then I need to multiply it by the entire circumference, which is 2 pi r. Okay, so for this one, we're going to go the length of segment or of arc PR is going to equal, we're going to do our central angle, 100 degrees over 360 degrees. That basically, these degrees then reduce out, so you're not dealing with degrees anymore. Times the circumference of the circle, which is 2 times pi times my radius, and my radius here is 12 inches. Okay, so simplifying here a bit, let's see. The zeros, I can divide top and bottom by 10, so basically those zeros reduce. So I'm left with 10 over 36. And those two can also be divided by 2. So I'm going to have 5 over, hold on, what divided by 2 is 18. Times 2 times pi times 12 inches. So my final answer will be in inches. Let's see here. So another thing that's happening here is I got some common factors. So I can, like, before I even get on my calculator, I can reduce this and maybe not even have to get on my calculator. 2 goes into 18, right? This is like 2 over 1. 2 goes into 18 9 times, right? So this becomes a 1. Now 12 and 9 have a common factor of 3. So if I divide 12 by 3, I get 4. Divide 9 by 3, I get 3. So it looks to me, if I multiply all the way across on the top, I'm going to have 5 times 1 times pi times 4 times inches. So that's going to be 20 pi inches. And in the denominator, it's just 3 times 1. So 20 over 3 times pi inches. So let's get an approximation for that. I think this is the best answer. But in case if in the back of the book you need to know, what you're going to want to do is you can do 20 times pi and then divide it by 3. 20 times and then get your pi. Press enter. You want to make sure that you get that value first and then divide that by 3. That's one way of getting it. And I'll round to the nearest thousandth. You could have also done, let's see, 20 divided by 3 first. Press enter so you get a value there, and then multiply that by pi. And you get the exact same thing. Oh, and let me just show you. So pi in our calculator. Right, so it's an irrational number, which means it goes on and on forever and never repeats, never ends. So it's like 3.141592654, and this, they've got this figured out to like millions of digits, but you know, that's what our calculator is giving us. So it's a more accurate value than just using 3.14, because there's a whole lot of stuff that happens afterwards. All right, so either one of these answers works for me. All right, now we have to figure out the circumference of this circle. Okay, so let's see what we've been given here. You know, circumference is 2 pi r. Let's use 2 pi r. Well, that's interesting. I haven't been given radius. So before I can do anything, I have to figure out what my radius is. What I have been given is I've been given an arc length. So maybe I can use that to help me figure out what the radius is. Okay, so I'm going to come up here. So arc length is basically the percent of the circle times the circumference. Well, percent of the circle you find by doing the central angle divided by 360. So central angle, I'll just do angle like that, divided by 360 times the circumference, which is 2 pi r. Now let's see, do I know any of this stuff? Well, I know my arc length, so I'll plug that in there. I also know my central angle, so I can plug that in there. And then the only thing I won't know is my radius. So I'm going to use a bit of algebra here. My arc length is 6.5 meters. My central angle is 130 degrees. That's over 360 degrees. So those degrees just actually cancel out. They reduce out. Times, and then let's do 2 pi r. All right, so let's see. I'm going to simplify this. This is really 13 over 36, right? Because those I can divide top and bottom by 10. The 2 will also go into the 36 18 times. So I've got 6.5 meters equals 13 over 18. I can do 13 over 18 times pi times r. Okay, I got to get r by itself. So let's see. R is being, first of all, it's multiplied by pi. So I can divide both sides by pi to get rid of pi. Okay, so now I'm left with 6.5 meters divided by pi equals 13 over 18 times the radius. Now how do I get the radius by itself? Well, it looks to me like the radius is being multiplied by 13 over 18. So I can divide by 13 over 18, but you can't divide by fractions. So instead you're going to multiply by the reciprocal. So the reciprocal of 13 over 18 is 18 over 13. I'll do that on both sides. These completely reduce, so I'm just left with r on that side. Let's come over here. So I'm left with r on the right-hand side. And then I got to get a value for this right here. So let's see what we get. 18 times 6.5 is 117. Okay, so I just did this. Divided by 13. So it looks like I'm getting 9 divided by pi, or 9 over pi. Oops. Or if I do that, to get an approximation, I'm getting approximately 2.865 meters. Both of these are in meters. And that's how, oh, but I'm not done. That's only my radius. So I am definitely not done here. I got a little excited. Good thing I looked back up at the problem. So now I need to figure out my circumference. Okay, so I figured out my radius. I'm going to go ahead and use 9 over pi. I'm not going to use this approximation because my answer will just be an approximation. So now I'm going to take this radius, 9 over pi m, and I'm going to plug this back in for r. So circumference equals 2 times pi times 9 over pi meters. Well, notice the pi's here reduce, right? So I've just got 18 meters. So circumference is equal to 18 meters. There's our final answer. Okay, so I had to find the radius first, and I had to use all the stuff I was given. I was given the central angle, I was given the arc length, so I knew I had to start by finding or plugging everything into my arc length to find my radius. Then I could take my radius. Once I did that, I could take this radius and I could plug it back in, and then I could find my circumference. So I kind of just outlined, there's step 1, brings me over here, plug that in, step 2. So you got to think about what you've been given. So now I want to find the measure of arc JK. Okay, well, arc length is always the same, is always equal to the central angle. So maybe we should write that down too. You know what? Let's write that on the front. I should say arc measure is always equal to the central angle. So arc measure is equal to the central angle. Let's see. And maybe I'll use a different color for that. So arc measure is always in degrees. Okay, so really what I need to figure out is I need to figure out the central angle. How about, what should I call it? I'll call it x. Okay, I need to know my central angle. Because once I know my central angle, then I'll know the measure of arc JK. Okay. And how do I know that they actually want the measure of this arc and not this arc? If they wanted the measure of this bigger arc, it would be the measure of arc JMK. So I need to figure out the central angle. Let's see what I've been given. I've been given the arc length, and I've been given the radius. Okay, so arc length is the percent of the circle, which is your central angle, over 360 degrees, and then you multiply that by the circumference, which is 2 pi r. So let's plug in things that I know. Okay, I know my arc length, so that's 21 meters. My central angle, I don't know, I just let that be x. So I'm going to do x over 360 times 2 pi r. 2 pi, and my radius appears to be 14.32 meters. All right, not much to simplify here, but I basically need to get x by itself. So I think what I'll do, let me go ahead and simplify the 2 and the 360, because the 2 is in the numerator. So that reduces to 1, and this reduces to 180. Not that that helped a whole bunch. And now what I'll do is I'll kind of write the whole numerator all together over the entire denominator. So 21 meters equals, let's go, x times pi times 14.32 meters, all over 180. Okay, I got to get x by itself. So first thing I'm going to do is get rid of this 180. X is being divided by 180, so I'm going to multiply both sides by 180. And that's actually 180 degrees, right? Okay, so maybe we'll go ahead and we'll use that this time. All right, so 180 times 21, let's see what that is. It's going to give us 3,780. And this is interesting, it's going to be 2 units. Degrees times meters. I know that looks weird, but we will figure this out as we move along. Okay, so I got rid of the 180, 180 degrees, gone. Okay, so what I'm left with here then is a pi, let's see, I'll go x times pi times 14.32. I've got to get x by itself, so what I want to do is divide by the pi times 14.32, and that's in meters. So I'm going to divide both sides here by pi and 14.32 meters, or pi times 14.32 meters. So watch what happens with the units here. See how these meters divide out? Those totally reduce. Everything over here has reduced except for the x. So I'm going to be left with x equals, and it's basically 3,780 degrees divided by pi times 14.32. So what I'm going to do is I'm going to take this and divide it by this. Okay, so I'm going to take 3,780 and I'm going to divide it by, and I'll take pi and multiply it by 14.32. And I'm getting approximately 84.023. This would be, like, you could leave your answer in this. This would be the most exact. But for us right now, I'm going to go ahead and put an approximation of 84.023 degrees. So the measure of an arc is always in degrees, and it's always equal to the central angle. I found the central angle, therefore I know that the measure of this arc is going to be exactly the same.